Good morning friends. Today topic is RUTC, RUCE, RECO, RUCM, DG shipping exit exam question and answer part 7. Question number 121. For survival, we can drink seawater in emergency. Option A, true. Option B, false. The correct answer is option B, false. If you drink seawater, it will lead to increase your dehydration. Once your dehydration increase, again you feel thirst and you will try to drink more water. So it will create dehydration more. You are already dehydrated and it will create more dehydration. So you should not drink seawater because the salt content in the water which will induce you to dehydrate more. So option B is the correct answer for question number 121. Question number 122. What type of the following is in soap locker? Option A, absorbent pad. Option B, torchlight. Option C, helmet. Option D, protection seal. In soap locker equipment, absorbent pads are kept and booms, other oil spill control equipment will be present inside it. So for question number 122, option A is the correct answer. Question number 1, 2, 3. If we are using 145 CST centistoke fuel and we receive new bunker which has viscosity more than 145 CST, what should we do? Option A, cannot use this fuel. Option B, change viscometer parameters. Option C, increase temperature of fuel. Option D, decrease temperature of fuel. The correct answer is option C, increase temperature of the fuel. Our main aim is, option C is the correct answer. Our main aim is in the fuel pump, when this comes to the fuel pump, it has to be heated up in order to bring the required CST as per the maker. When you are injecting the fuel injection on the fuel injector, they say that it has to be maintained from 3 CST to 15 CST, some engine 2 CST to 20 CST, like that they will give in the range. So our aim is at the point of injection, it has to be maintained that CST as per the maker. So whatever the fuel oil, different viscosity we are receiving, we have to heat it up. The heated temperature is given by your lab analysis report. So they will say how much temperature to be heated for transfer, how much temperature for injection, all details they will give. You have to maintain the tank temperature, line temperature accordingly. So for question number 1, 2, 3, option C is the correct answer. Question number 1, 2, 4. The advantage of thyroids over an engine without thyroids is that option A, the engine is very easily aligned after any misalignment has taken place between different components of the engine. Option B, the engine does not require thrust pads for transmission of thrust to the ship's hull, as the same is being taken care by the tie rods. Option C, the engine components are much lighter, leading in overall reduction is engine weight with a high power generation with the elimination of fatigue stress. Option D, there are no advantages of engines with tie rods because tie rods require regular maintenance and replacement like connecting rods, and overall engine becomes more expensive to operate. The correct answer is option A. The engine is very easily aligned after any misalignment has taken place between different components of the engine. So the tie rods will be guiding for arranging of your cylinder block or interpolature, your A-frame, your bed plates in a line. So it is easy. That is the advantages. So question number 1 to 4, option A is the correct answer. Question number 1 to 5. The purpose of an air cooler in a supercharging system is to option A, reduce temperature of supercharged air in order to condense and remove maximum possible moisture from the air prior entry into the engine. Option B. Reduce the temperature of the supercharged air in order to increase the density of the air and also to cool down below dew point to remove moisture from air prior entry into the engine. Option C. Cool supercharged air to increase its density so that the dew point is not reached to avoid entry of moisture into the engine. Option D. Cool supercharged air to increase its density and also to keep the peak temperature and exhaust gas temperature within limit. The correct answer is option B. The purpose of the air cooler is to increase the density of the air. The heated air will be more expanded. The molecules are loosely packed. When it is cool, it comes closer. So density of the air is increased. And when it's cooling, any moisture in the air, it is get condensed below its dew point and become water. It can be separated in the water separator in the air cooler. Then it passes to the scan space. So it helps to avoid any corrosion effects, other delay firing, automation, firing of the engine also. So for question number 1 to 5, option B is the correct answer. Question number 1 to 6. Which of the following is an example of a solid bearing? They are telling me which one is a solid bearing. Option A, piston pin bushing. Option B, turbo generator turbine bearing. Option C, spring bearing. Option D, thrust bearing. The correct answer is option A, piston pin bushing. The piston pin bushing is a whole bush itself a bearing. It's a solid one. Option A is the correct answer for question number 1 to 6. Question number 1 to 7. In comparison to exhaust valve, intake valves of diesel engine may be fabricated from low alloy steel because option A, the beveled edges of the intake valve provides for self-centric during seating. Option B, intake valves utilize stellite coated valve seat insert which reduce wear. Option C, the volume of air passing through intake valves is less than the volume of air passing through the exhaust valves. Option D, intake valves are less affected to the corrosive action of exhaust gas. Correct answer is option D. The intake valves are less affected to the corrosion action of exhaust gas. The exhaust gas passing through the intake valve is less compared to the exhaust valve. That's why the stellites are used on the exhaust valve. Okay. So for question number 1 to 7, option D is the correct answer. Next question. Question number 1 to 8. Why is it essential to renew turbocharger bearing after preset number of hours of running, even if the bearing are in seemingly perfect condition? They are telling after the particular running hours, 16,000 running hours, 14,000 running hours, you are changing the bearing, turbocharger bearing without checking the condition. We are changing because we don't want to take risk. So why you are doing it? Even if you find it is good condition, why you are doing it? That is the question. Option A, because they are prone to failure due to prolonged exposure to high temperature condition. Option B, because they are subject to cyclic loading and are prone to failure due to metal fatigue. Option C, it is not essential to renew if condition monitoring suggests perfect condition. Option D, lube oil contamination is bound to occur and affect the condition of the bearing. So the correct answer is option B, because the bearing undergoes a cyclic load. Okay, and also metal fatigue is more possible older. So that is the correct answer for question number 1 to 8. Question number 1 to 9. Modern marine turbochargers are used a dash type of compressor. Option A, radial flow. Option B, axial flow. Option C, mixed flow. Option D, turbulent flow. The correct answer is option A, radial flow. The main aim of using the radial flow turbocharger in the turbine side is mainly because it is complex structure, simple in construction, and the effect of compression of the air is high compared to the axial flow. That is the reason. So for question number 1 to 9, option A is the correct answer. Question number 130. In a two-stroke marine diesel engine, if the o-ring for jacket cooling water sealing is leaking, then option A, the water will leak directly into the crankcase. Option B, the water will leak into the under piston space. Option C, the water will come out through a telltale hole provided between the two o-rings. Option D, the water will come out from the top of the cylinder jacket. The correct answer is option C, the water will come out through the telltale hole. So don't worry, the water will not go into the system, to the combustion area or into any other place. Okay, for question number 130, option C is the correct answer. Question number 131. The lube oil pump used in a diesel engine is a option A, volute pump, option B, centrifugal pump, option C, diaphragm pump, option D, gear pump. Gear pump is the first displacement pump and the clearance is very less, so we use in lube oil system for pumping into the generator from the sump to the bearings. So for question number 131, option D is the correct answer. Question number 132. Which of the following statement is true above slow speed engine? Option A, a scavenge fire can lead to a crankcase explosion. Option B, a scavenge fire can lead to deformation of the diaphragm plates. Option C, a scavenge fire can lead to damage to tie rods. Option D, all of the above. The correct answer is all of the above, D. Because if there is a scavenge fire in a slow speed engine, it can damage the diaphragm plate also. It can pass through the stuffing box and can lead to increase the temperature of the crankcase and can expect of crankcase explosion. A scavenge fire can also, due to the explosion scavenge fire, there will be difference in pressure that can damage your tie rods. So all the above is the correct answer for question number 132. Question number 133. For a two-stroke engine, in two o-rings are provided on the liner. The function of the top o-ring is to dash and function of the lower o-ring is to dash. Option A, sealed jacket cooling water act as a secondary seal in case of first o-ring leaks. I'm telling is like a backup. Option B, sealed jacket cooling water, second o-ring is sealed scavenge air. Option C, sealed scavenge air, second o-ring sealed jacket cooling water. Option D, sealed combustion gas. Option second o-ring is sealed jacket cooling water. The correct answer is the top o-ring is sealed jacket cooling water, the bottom o-ring sealed scavenge air coming into the jacket side. So option B is the correct answer for question number 133. Question number 134. Even if there is an oil mist concentration inside a crankcase and there is also a hot spot, crankcase explosion will only take place when option A, the hot spot provides the ignition temperature for oil mist concentration. Option B, when the oil mist air mixture is in flammable range. Option C, both A and B. Option D, none of the above. The correct answer is option C, both A and B. It is the hot spot temperature is sufficient to catch the fire, and also the air fuel mixture ratio should be in the flammable range. Then only the fire can happen. Okay, same like fire triangle: air, fuel, heat. Got something. For question number 134, option C is the correct answer. Question number 135. What do you mean by surge limit of turbocharger? A characteristic curve of a turbocharger. Option B, portion of compressor characteristics curve which lies on the left side of the point of maximum pressure. Option C, a line joining all the points of maximum pressure and compressor characteristic curves drawn at various speed of the operation. Option D, maximum RPM limits of temperature above which surging will start. for this search can happen is option C. In the maximum pressure of the compressor is drawn in the compressor characteristic curve at various speed of the operation. The point of contact is the point that the search limit more than the searching happens. So option C is the correct answer for question number 135. Question number 136. A large low speed main propulsion diesel engine uses seawater to directly cool the option A cylinder head, option B exhaust valve, option C scavenging air, option D injectors. Correct answer is scavenging air, option C. So in air cooler we can use a seawater system, okay, not a jacket water system. Okay, the jacket water system should be always the freshwater system. Okay, so for question number 136, option C is the correct answer. Question number 137. Which of the following factors affect penetration of fuel droplets during injection? Option A, quality of automation, option B, injection temperature, option C, scavenge air pressure, option D, all of the above. The correct answer is all of the above. Penetration of fuel droplet, that is passing of fuel droplet through the injector, is mainly dependent on the quality of automation and also the temperature of the injection and scavenge air pressure. So option D is the correct answer for question number 137. Question number 138. After prolonged operation, jerk type fuel pumps wear on top edge of the plunger and edge of the spill ports and helix due to erosion by high pressure fuel as it spills. This wear would result in, they are trying to say that your plunger, helix plunger, there is a erosion, crack, means there is a erosion, loss of material is present in it. So when you are compressing the oil, what will happen? Okay, so option A, late start of injection and early end of injection. Option B, early start of injection and late end of injection. Option C, early start of injection and early end of the injection. Option D, late start of the injection and late end of the injection. The correct answer is option A, late start of the injection and early end of the injection. That means oil is leaking from the top of the plunger through the helix to the spill port at the suction side. This is happening. So the injection will be delayed. The amount of injection is also less. So option A is the correct answer for question number 138. Question number 139. A labyrinth seal fitted on the back surface of the compressor wheel of a turbocharger. Option A, prevents bearing lube oil contamination. Option B, prevents bearing lube oil being sucked into the airstream. Option C, helps to keep the shaft cool by controlled leakage of air. Option D, none of the above. For question number 139, option C is the correct answer. The labyrinth seal will not completely seal the air to pass through. It will allow the air to leak very less, very fine, and that flow of air will cool down your shaft. So cooling effect also happening. That is what it is doing. So question number 139, option C is the correct answer. Question number 140. It is a known fact that centrifugal pumps require priming for pumping liquids as they cannot handle air and will lose suction due to air entry. But on the other hand, turbocharger use centrifugal compressor for supercharging. Which of the following do you think makes a centrifugal compressor to pump air and behave differently than the centrifugal pumps? Option A, presence of air cooler. Option B, presence of labyrinth seal. Option C, high speed of rotation, very fine internal clearances and a large impeller diameter. Option D, difference in operation of principle of operation. It is main difference between the centrifugal pump and the turbocharger is running at the high speed of rotation in the centrifugal pump, and the clearance between the moving part and stationary part is very less, like the moving turbine blades and the nozzles, stationary nozzles. Blades are fine blades, larger diameters, the impeller that is currently larger impeller. The blades, turbines are also called as a larger impeller. Diameter of the impeller is high. These are the fact. It is the reason for the turbocharger can be able to compress the air, but it cannot able to remove the air from the centrifugal pump. Cannot activate a positive displacement pump. This is the reason for question number 140. Option C is the correct answer. Okay, friends. Thanks for your support. If you like my video, please like. If you want to see more videos, please subscribe. Any doubts, comments, any suggestions, welcome in the comment box. Thank you.